We are starting with exercise number 6 of permutation, that is circular permutation. Okay, so the basic formula over here is if certain objects are arranged in a circular manner, one object is taken as a reference point. Okay, this was discussed in class as well. Okay, so the formula is n minus 1 factorial. Okay, now a b c d and a b c d. Okay, this both appears to be same. Okay, because one is taken clockwise, one is taken anti-clockwise. So if we don't have to consider clockwise and anti-clockwise and consider it same, the formula becomes n minus 1 factorial upon 2. So where to use the second formula? Second formula is used specifically in the necklace and garland problem. You should remember that. And whenever they say that a person cannot have same two neighbors. See, in this case, A has neighbor B and D. Again, A has neighbor B and D. So if we don't want to use the same two neighbors, you can use this second formula. And the first formula is without any restriction. A person can have same two neighbors, okay? Yeah, so this is the starting point. Exercise number 1, exercise number 6, question number 1. In how many ways can 4 persons A, B, C, D be seated in at a circular table? So there is no restriction put over here. N is equal to 4, so circular permutation, 3 factorial ways. Okay. Second problem. In how many ways can 6 persons be seated around a circular table? So n is equal to 6, n minus 1 factorial, which is equal to 6 minus 1 factorial, which is 5 factorial. Third one. In how many ways can 5 persons A, B, C, D, E sit around a circular table if B and D sit next to each other? Okay. First part. So B and D is the reference point. B and D is the reference point. It is considered as one object only because they are together. The remaining 3 objects, they can be seated over here. So the total number of objects are 4. Total number of objects are 4. Okay, because B and D is considered as one object itself. So for 4 objects, the circular permutation is n minus 1 factorial, which is equal to 3 factorial 4 minus 1 into within the first object. It can be BD or DB. Arrangement can be BD or DB. So 2 objects, 2 places, 2 factorial ways. So this should be your answer. Okay. Second subpart. A and D do not sit next to each other. Now first step 1, n is equal to 5 objects, n minus 1 factorial, which is equal to 4 factorial, which is 24. Now this is without any condition. These are the total arrangements in a circular way. Step 2, A and D sit next to each other. So A and D is the reference point. 3 more objects over here. So now the total number of objects are 4 because A and D is considered as one single object. So 1, 2, 3, 4. 4 objects are there. Okay. So n minus 1 factorial, 4 minus 1, 3 factorial. But then I'll multiply with 2 factorial also. Because within the first object, AD can be DA also. So 2 objects and 2 places, 2P2, 2 factorial ways. So this is equal to 12. Step number 3, A and D do not sit next to each other. So it is step number 1 minus step number 2. Total ways minus the ways in which they are sitting together. Okay. Yeah. So question number 4, you can do it on your own. It's similar to question number 3. Question number 5. Okay. In how many ways can 4 ladies and 4 gentlemen be seated around a round table so that all ladies are together? So all ladies L1, L2, L3, L4, they are together, and the gentlemen will, you know, be separated, or they may or may not be together. But then the ladies will be together. So this is the reference point. It's the first object. Okay. And for four gentlemen, we'll reserve four places. So the total number of objects are five. One, two, three, four, and five. Because all ladies are considered as a single object. So n minus 1 factorial, which is equal to 5 factorial. Now 5 factorial will be multiplied with 4 factorial because within the first object, there are four um, objects. So that will be 4p4, which is 4 factorial. Just a second, this should be 4 factorial because 5 minus 1, that is equal to 4. Sorry, 4 factorial. Okay. So this 4 factorial into within the first object, there are four sub objects. So it will be 4 factorial ways. Okay. This is the fifth one. Let's go to the sixth one. Okay. Six persons sit around a round table. Six persons sit around a round table. So how many ways they can sit together so that no person has the same neighbors? So this is with restriction. You can use the second formula n minus 1 factorial upon 2. Same neighbors are not allowed. Okay. So 6 minus 1 factorial upon 2. 5 factorial upon 2, which is equal to 60. 7 sub question 1. Necklace problem. N minus 1 factorial upon 2. So 6 minus 1 factorial upon 2. Okay. 60. Second problem. They are having the same color. Now if the necklace in a necklace, if all beads are of the same color, then how many such necklaces can be formed? If all are red, all colors are red, there is only one necklace that can be formed. If all are blue, there is only one necklace that can be formed. Okay. Question number 8. So now there are six men and five women. Okay. And they are seated in such a way that no two women are together. So first we will, you know, arrange the men. So women have to be separated with a man in between. So this is the reference point for the men. So men, there are six. So n minus 1 factorial, which is equal to 5 factorial 6 minus 1. Okay. So this is 5 factorial for men. Now I'm putting a tick mark, or rather I'll just put a star. Star is a place for woman. Okay. Women will go and occupy themselves at this star marked place. So woman number 1 can be seated in 1, 2, 3, 4, 5, 6 ways. Woman number 2, 5 ways because one place is occupied, one star is occupied. So now there are only 5 stars. Woman number 3, 4. Woman number 4, 3. And woman number 5, 2. So the final answer will be arrangement of the men into arrangement of the women. So that is 5 factorial into 6, 4, 3, 2, 1. You have to multiply this. So technically it is 5 factorial into 6 factorial. Now this 6, 5, 4, 3, 2 can also be written as 6p5. Starting with 6 and we are writing 5 times. So either you can write 6 factorial or 6p5. Okay. Next problem. Let's go to question number 9. In how many ways can three ladies and three gents be seated around a round table so that two and only two ladies sit together? Okay. So men, there are three men. Okay. Three men, n is equal to 3, n minus 1 factorial. 2 factorial. So the arrangement of men is 2 factorial. One man I'm taking as a reference point. So there are 3 men. Okay. Now there are 3 places for the ladies. 1, 2, and 3. Okay. So now let's say L1, L2. L1, L2 can sit over here, here, or here. So L1, L2 can be seated in 3 ways. Okay. Then L3. L3 can be seated in 2 ways. Because if L1, L2 is sitting over here, there are 2 places left for L3. Okay. Right. So this is for L1, L2, L3. Similarly, or L2, L3 can be seated in 3 ways. It's not necessary na L1, L2 is going to sit together. L2, L3 can also sit together. Okay. And L1 in 2 ways. Okay. Or, okay, L1, L3 in 3 ways and L2 in 2 ways. Now see, if L1, L2 are sitting together, it is not necessary it will be L1, L2. It can be L2, L1 also. So this answer will be 3 into 2 into 2 factorial. And rather, every answer will be 3 into 2 into 2 factorial. Because L2, L3 can be L3, L2 also. 2 factorial because 2 objects, 2 places. 3 into 2 into 2 factorial. So these are 12 ways. These are 12 ways and these are 12 ways. So 12 threes are 36. Okay. So there are 36 ways in which female or ladies can sit. And men will be 2 factorial. So 36 into 2 will be 72. So first I arrange the male into factorial ways. Now female, I have considered cases. Now in each case is similar. And each case has a solution of 12. So there are 3 different cases. So cases is it's always OR. So 12 plus 12 plus 12, 36. And men are arranged in 2 factorial, which is 2 ways. 36 into 2, 72 ways. Question number 10. A round table conference is held between 20 delegates. How many seating arrangements are possible if 2 delegates are always next to each other? So now there are 20 delegates, n is equal to 20. So without any restriction, n minus 1 factorial 19 factorial ways. So they can arrange themselves in 19 factorial ways. Okay, now first part, always together. So 2 delegates are always together, D1, D2. Okay, this is the reference point. Now remaining delegates. Okay, 1, 2, 3, dot, 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 18. So these are 18 delegates. Star are delegates, the remaining delegates, which are not D1 and D2. Okay. So it will be from 1 to 18. This people will sit over here. Okay. So total objects are 19 because D1, D2 is considered as one object. So n minus 1 factorial, which is equal to 19 minus 1, 18 factorial. Now 18 factorial will be multiplied with 2 factorial because D1, D2 can be D2, D1 also. Okay. So the ways in which the 2 delegates can sit together is 2 into 18 factorial because 2 factor is 2. Now never together. They can never sit together is step 1 minus step 2. Total ways minus 2 are always together. Okay. So you can take factorize this. 17 into 18 factorial. Okay. Third part. The two specific delegates are separated by exactly one person. Third part. Okay. So this is a circular table. The delegates are going to sit over here. So I'll just mark this delegates dot dot dot. Now these are 18 delegates. Okay. So D1, D2 can sit over here. Okay. So now see, I'll make it more simple. Now, first of all, this 18 delegates will sit into 18 minus 1, which is 17 factorial ways. Okay. Now let us consider not 18, but then let us consider only 4 delegates. So D1, D2 can sit over here. 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 Because they are supposed to be separated by other delegate. Again, I repeat, let us consider only 6 delegates. So 4 delegates are going to sit in at those star mark place. Now D1 and D2 can sit over here like this, or like this. Second way, or like this, or like this. So when there are 4 stars, they can sit in 4 different ways. So if there are 18 stars, if there are 18 stars, so they can sit in 18 ways, D1, D2. Now it is not necessarily D1, D2, it can be D2, D1 also. So those can be reversed, D2, D1. So D1, D2 can be changed to D2, D1 in 2 factorial ways. Okay, so this will be 17 into 18 into 2 factorial. 17 factorial is the arrangement of the delegates who are not going to have any separation. Those are the delegates which are not a part of those 2 delegates, okay, which are going to be separated by a delegate. Okay, 17 factorial, sorry. Now 18 into 17 factorial is 18 factorial. So 2 factorial into 18 factorial. 18 into 17 factorial is 18 factorial. So this is the final answer. Question number 11. So now in this particular problem, Virat is flanked by Rohit and Dhawan. So Virat is in between Rohit and Dhawan. Okay. So 3 players are here. This is the reference point. 1, 2, dot, 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 dot. How many stars will be there? 8 stars. Because 8 plus 3 is equal to 11. Total number of objects are 9. 8 stars and this is one object. So 9 minus 1 factorial, which is equal to 8 factorial. This is the arrangement of these 9 objects. Okay. Now within the first object, Virat's position is fixed. So RVD can be DVR also. Okay. Rohit and Dhawan can interchange their positions. So 2 objects and 2 places. Hence 2 factorial ways. I'm not going to count Virat because Virat is in between. His position is fixed. So the final answer over here is 8 factorial into 2 factorial. Fine. That's the end of circular permutation. Thank you.